Hello and good Saturday to everyone. It's been a while since I've done one of these, but I wanted to kind of share progress of what I've been working on. And so I've been working on the BSV21 indexers or overlay. And for anyone who's not really understanding what overlays are, they're essentially they're a system that has a kind of a predefined filter of what transactions they care about. But an overlay takes care of all the work of getting SPV proofs and essentially acting as if you're running a full node, but only for the subset of transactions that you care about. And then in an ideal world, everyone who cares about whatever the topic is you're thinking of or you care about or you're looking into, those nodes will form peer relationships with each other, and everyone kind of is kept in sync with the full state of whatever transactions you want to slice and dice. And so this is particularly about keeping individual BSV21 tokens fully indexed, fully validated, such that, let's say you wanted to run a store that accepts payments in money or in bamboo token or whatever token happens to come to being or be worth value or whatever. You can actually on your server have one of these, or on your computer or whatever, have this full overlay up to date about that token that you're going to receive. So it's not like you don't have any resources dedicated to this project. You definitely do, but in some ways you're basically running a full node of just this one token. So people who want to accept money will be running full nodes of a money overlay, but that's it. They don't have to care about any other transaction on the chain anywhere. They only have to care about the money transactions, or name your other. Like, this also allows then for people to do kind of true offline markets, or offline. I don't know what I mean by offline. Decentralized markets, such that you can really have things that you can sell. You can have swaps. You can do all sorts of DeFi stuff. You can do whatever on a truly peer-to-peer basis. But that's getting ahead of it ourselves. Let's just start with trying to clone this code and get it set up on this server and see what lessons I learn about what still needs to be done. So we're going to clone from GitHub, be OpenIO. What am I looking for? BSV21 overlay. There it is. Open. Okay. Okay, so apparently I already had this cloned previously. Let's do this. I sure did. All right, RM minus RF BSV21 overlay 1. Okay. So first thing we're going to need to do here, and this is in the README, but it might need some more clarification. We're going to create a .env file. Oh, apparently I already have one of those too. We don't need this. Okay, this is all from previous attempts, and those are no longer valid. Okay, so what we need, so this actually runs on a couple of different systems under the covers. So we definitely need a block header service. So this is, it's a package you can download from the BSVA's GitHub. I think it's called block header service. There's a little config where you put a couple different values and you spin it up, and it just gets on the peer-to-peer network, gets all the block headers for all of the network. Speaking of which, Okay, I do have it running. I should restart it just because I haven't even looked at this computer in several months. Okay, it looks like it's doing stuff. Okay, so you need a block headers URL. You need, actually, I don't think we actually need Redis, and that's not what it's called anyways. What we do need then is, so there are a couple different databases that this can use, but it also uses Redis as kind of like for some things always. So for the actual kind of the inner workings of the lookup service, of the overlay service, I've got implementations here for Redis, for SQLite, and for MongoDB. And what we're going to play with right now is going to be MongoDB because I've tested this on other machines. So we're going to stick in our Mongo URL. Oh, so with the Redis, I didn't say. So you can have a Redis URL for, let me just paste in this other. This is my config. Oops. This is my config from another environment. We don't need Jungle Bus. That can go away. Okay. So there's the beef storage, which is like one of the interfaces I've got. That needs a Redis connection of itself. That can be the same Redis instance as what we connect to for other things, but it doesn't have to be. Anyways, this is actually running KV Rocks, which is the Redis interface, but in a disk-based system. That's what this Redis beef is. So essentially, every time I'm saving transaction proofs, they're the beefs for a transaction, that's getting just stored on the file system. I don't think we need that. Okay, so we have this event storage that is set to Mongo. That's going to tell it to connect via our Mongo connection string to our Mongo instance rather than a Redis instance or a SQLite. And I can certainly add a Postgres or MySQL adapter for this later. I just am trying to go for quick prototyping stuff. Okay. We need block headers. We need beef storage. We need our database. We're going to get back to that in a second. We don't actually need that. Okay. So here's what I think is our main configuration that we're going to need. So then peers. So in the whole overlay system, there's a few things that are already, we'll say, well-defined as for how kind of the peer-to-peer syncing within these overlays works. But that is got some things that come along with it of that's assuming that all your peers are people who have REST connections and who will. So like when you spin up your node, there's this whole ship protocol, which is another BSVA thing that or Babbage thing that Ty came up with. That's all kind of about announcing on chain that I am listening at this URL for this overlay topic. You can do all that. I'm written all this stuff in Go. We're still kind of working on that stuff for the Go side of things. So right now I'm just using basically hard-coded peers. And this, let me actually pull up where I've got this stood up remotely. Where is my URL? Where is my URL? That is not the right thing. Well then, I know I've got this standing up somewhere. Well, you know what? I can just use, we're going to use BSV21.shrugger.cloud. This is actually just going to hit something I've got running locally that may or may not stand up until I can find the actual the one I've got deployed locally. Okay, so I'm specifying peers here. This can be a common delimited list if you have more than one peer. Again, the whole sync side of things, I'm still just getting my feet under me. But, okay, so now that I've got that stuff, if I go into, actually, let's just go command server. Oh, I never pulled. Git pull. All right, so we're going to go run dot got to download all our dependencies for the first time. Speedy. Boy, I've got some old dependencies here. I have no idea what they're from. Okay. Oh. Okay. Well, maybe I do need Redis URL. Okay. So this is my server up and running. So if I start it up again and include the -s true switch, it should start reaching out. Let's see, is my other server even running? Oops. So let's bring this over here. So here's my other server. Okay, it should be running. PM2 logs 1. Oh, I need a /API/v1 on the end of this path. That's why. Oops, wrong one. Oh, no, I have it. Oh, it's sending something invalid. Interesting. This is literally the first time I've actually set this up from scratch. All the other times I've been still working on development side of things. So let's close the sidebar there. Okay. Oh, what do we got here? Oh, no, that's still our logs. It logs out all the routes that are available. Starting GASP sync, starting server on port 3000. Oh, that was last time I started it. Let's actually make sure this. Oh, that needs an S. I bet you that's it. What is going on here? Okay, hold on a second. We're going to go into, not that, server.go. I'm going to turn off these. There we are. Make my logs a little more concise. Starting GASP sync. This did not get anything. Let's go PM2 restart 1. Oops. All right, well, this is not forwarding across. So let's pull up a Postman and see if I can hit that. Okay, so I can hit it from here, but not from here. What do I have wrong in my environment? Do I need, oops. No. Oh. Oh, I don't need the port because I'm going through. Yep, that explains it. Okay. That still isn't working. Oh, I know why. Okay, so how I have this whole BSV21 indexer set up, it's going to automatically try and spin up and sync whatever tokens you whitelist. And I didn't actually whitelist any yet. So this is my Redis database. So I'm going to say BSV21 whitelist. And I should have checked. Oops. Well, let's go to the other system. Boop. BSV21 whitelist. And I'm pretty sure this one is money. Let's go back to the other one. New key, BSV. Oops, it was already there and I just typed over it. Okay, this is going to be a set. Okay. Now, when I do this, boom. Okay. So just by simply me adding this token and obviously having a known peer that's hosting these token services, as soon as this thing starts up, it starts pulling up. So this is actually pulling in right now every money transaction that's ever happened. Well, I should say up to a day or two ago, whatever is synced on this other server. So like, for example of a case like money, this is something that maybe an exchange will run. And an exchange can actually validate all the money tokens themselves without needing to rely on a one-set indexer or rely on money servers or anything like that. So if I go into the actual code of what's being done here, let me make this bigger now. So topic manager. So overlay services are built up of kind of two different configurable pieces. One is called a topic manager. And that's really for looking at a transaction that comes in, and within the context of the overlay, meaning, okay, the overlay already knows about its inputs and whatever it needs to do to validate. It looks at a transaction in its full beef form. So beef, again, is when a new transaction gets broadcasted, you've got the transaction, but you also have proofs of all of the inputs that are included with that transaction. And in those proofs, you actually have the input transactions themselves, and therefore what the scripts are and what all kind of the context is. So in BSV21, they are not minor validated. So essentially that means that you could create a BSV21 token, or you could create a transaction that contains what looks like a BSV21 token, but it's a counterfeit. It didn't actually come from the place on chain where this token was deployed. And kind of the cool thing about BSV21s and other types of tokens, I guess this is kind of the whole ordinals world as well, is if you have, well, specifically with BSV21. So every token has a token ID. And that token ID is the location on the chain where that token came into existence. And so when a BSV21 is deployed, all of the supply of that token is deployed at the same time. And so every UTXO that you have that is for a BSV21 token, if you track its chain back, it will have come from that token ID. So written in the outputs is a token ID, and that tells you everything you need to validate that, okay, if I can crawl back, validating all the rules for every transaction and get back to the transaction that has this token ID, then this is a valid token. So what this is doing right now is it actually reached out to this other peer of this overlay, and basically from the beginning of this token, it basically said, okay, let me process and ingest every one of those transactions into the system. With money, there's about 30,000 of them, so it takes a little time. And the one thing with the BSV21 tokens is, unless you're going to kind of like pre-process everything and figure out what the dependencies are, for a given token right now, I'm finding it's easier to just process them in series. Now, once we start getting tokens where there are millions of transactions every day, well, then probably processing in series, well, even millions, it's not really that many. I mean, you can see this is not optimized at all, and I'm zipping through them in, I don't know, looks like 10 or 15 a second or so. So it's not really that big of a deal. And this is really just the initial sync. So if anyone wants to put optimization on that later, we can do that. But for now, we don't need optimization. So what this is really doing is this is the topic manager. So topic manager is all about looking at a transaction, figuring out, does it match the criteria to be included in this overlay? And that's really all it does. So it's just a filtering mechanism. So what we're doing here is we're basically, okay, so this thing takes in the whole transaction beef that's being provided. It takes in a map that basically says, okay, these are the previous coins, the previous inputs from this transaction that are already present within the overlay. And it's going to give you the outputs for that transaction. So essentially this is, when I process the first transaction for a token, this is going to be empty because there's nothing that exists in this overlay at all. But then as soon as it processes that first one and it gets the fact that, okay, now I have one output, well, now that next transaction that spent that output is going to get that output in the context that's being passed in here. And I guess just to go back in the kind of the more basics here. So the topic manager takes in the beef of our current transaction and which outputs or which inputs already existed in the system. And what it returns is this simple struct here that basically says this outputs to emit is saying which of the outputs of this transaction belong to this overlay. Coins to retain says which of my inputs were spent in this transaction do I want to keep in the overlay for other proofs or other context or whatever else. If you don't specify them in coins to retain, the overlay will essentially delete them. So you can build overlays that are very much about current state of things and doesn't care about any of the histories. But everything in kind of the one set ordinals world and in the BSV21 world, you kind of have to have the whole history to prove anything. So in our case, every one of our inputs is also going to be kept. And this ancillary TXIDs, this actually is not in the TypeScript version yet. I don't think so, of overlay services. This is basic. So with beefs, kind of by default, as we start getting proofs for the inputs, or as we start getting proof for the transaction itself that we're looking at, and it has a Merkle proof, then all of its children kind of fall off of it. So as the beef is getting updated with new Merkle proofs, as the chain moves on and as things get mined, it would normally drop certain input transactions out. In this admittance instructions, there is this other array that can be set of ancillary TXIDs. what that's really saying is transactions which were included in this beef, regardless of whether the end transaction of the beef gets mined or not, these are the transaction IDs from that beef that we need to keep around with this beef because they're important information about proving out what this transaction is. So that's something I kind of had to add to the overlays to support the kind of stuff we need in ordinals. Because in ordinals, you need to be able to keep certain inputs so that you can calculate how many Satoshis were in them. And if your beef drops off all those inputs and you don't have that information anymore about how many Satoshis were in those inputs, and those inputs were just BSV inputs, so they didn't actually fit whatever overlay you're doing, well, in that case, we need to make sure that those get kept around with the beef. And so that's what this ancillary TXIDs is. So that's really all this topic manager does. It just figures out, is this a valid instance of, in this case, of BSV21 tokens? So it goes through, I mean, it decodes it. So it makes sure that, okay, we have an inscription. It is a BSV21 inscription. And it goes through kind of rules. And it looks at the input amounts and the output amounts. And it makes sure that those add up. And just kind of all the validations of the token system. And then ultimately, for everything that's valid, if has token admit, where's this admit? Okay. So we do all the math, we figure out what's valid, and then we kind of specify, okay, these are the outputs that do indeed belong to this overlay. Now, if they're invalid for whatever reason, they will not get added to the overlay. So we don't really have, from an overlay standpoint, validation into why things were excluded. So, I mean, that's part of just kind of the development process for whatever topic you've got, is you got to make sure that the rules are actually implemented right. Otherwise, it'll start dropping transactions out. Okay, so that's essentially it. So what it's doing right now is it is going out, it is getting every transaction and processing them one at a time through this topic manager and just figuring out what matches and what doesn't. Let's go back over to Mongo. Okay. So what that actually stores, so this is kind of the base data around overlay services. I created a Mongo implementation there. You can, again, this can be any database you want to use. I've got a Mongo one, I've got a Redis one, I've got a SQLite one that I'm going to extend to other SQL implementations once I get some time and prioritize. So what this really does, one thing is it just keeps track of, oh, I didn't really talk about topics. I should do that quick. So everything in overlays are kind of narrowed down to one topic at a time. So in this case, I have got not just a generic BSV21 topic. I actually have a new topic, a new instantiation of this exact topic manager for every different token that I'm indexing. And right now, that is literally just this one, just money. Money is the only one I've got in here right now. So when this thing spins up, it basically says, okay, I know about this topic. So all topic managers, their actual code starts with TM underscore. So if I look at these records, I go in topics, you'll see the topic is TM underscore and then the token ID. So this is the topic that everything kind of sync on. So when I stood up this server right here and it built out a topic manager for this token, when it reached out to this other server and it did its initial sync call, I don't actually have the code there to show that sync call. It passed in that basically I want to sync all the transactions from this topic ID. Now, if I had other tokens in here, there'd be other sync processes going in the background as well. I don't remember how concurrently or how sequentially that happens, but it's basically going to reach out and kind of try and keep in sync about that topic. And that's kind of the key that's used. So if I go back to my server here and I go to my nope, up here. So we kind of initialize this engine. This is the overlay services engines. This is part of the kind of the core library in the BSV blockchain GitHub repo. And okay, so here I'm actually looping over all the values that are in that whitelist, and for each one of them, I'm creating a topic manager whose name is TM underscore, then the token ID. So when this thing spins up, every token that it's following, it's going to get its own topic manager for. And then when transactions are submitted into an overlay, that submission process actually explicitly states these are the topics that I'm submitting this transaction to be part of. So unlike just kind of like the old world of you just fire transactions to a node somewhere and they get mined somehow, and then some exchange or some explorer picks them up later on for you to find out about. In all this overlay world, the overlay itself kind of controls everything. Transactions are broadcasted through the overlay. The overlay does its own validation, figures out is there any errors. If there are, that transaction never gets submitted in the first place. But if there's not any errors and it looks good as far as the overlay service knows, then the overlay will broadcast it to Arc. It'll process it as if if it will be mined, and then it keeps communication channel open with Arc to, one, get the Merkle proofs when it's actually mined, or if it's double spent, or if it doesn't get mined for some other reason. That's other thing. Now, I'm not sure how strong mitigations we have built in. I mean, the assumption here very much is you're not like anytime you get cases where the overlay gets out of sync with the chain, then likely how you decided to set everything up and build everything there shouldn't really be opportunities to do that. Now, in some cases with some rules, if you have malicious users, you could have cases where you need alternative means to kind of populating your overlay, but you can also build rules into your overlay such that you need certain processes that you can't really do outside of the scope. Maybe there's an Oracle signature on things, or it all really depends on what your use case is. This isn't trying to necessarily solve all the problems. This is more just these are the tools we're working with to be able to solve problems. So now that this is up, let's go. Let's take off the S. Check. I think I'm running it on 3000 there. Oops. Yes. Okay. So how this overlay services, let me go back to my server here. Way down at the bottom. So the overlay services tooling is kind of all self-contained. So like everything else I've got stood up in my web server here is all just my own routes that are very specific to BSV21 and what this server is running. But under the covers of that are kind of the standard API for overlay services. And that is called with this register route. So when you see, let me go back over here. When you see like this API v1, anything that's namespace API v1 is part of like that standard API that's well-defined within the overlay services. So that's really about kind of defining the interface by which overlay services can sync with each other. But higher up in this server, I've got a bunch of APIs or routes that I've defined that are really about, this isn't about just kind of general standard overlays stuff. Users need to be able to query into this to find out, okay, what does this token look like? Or how many UTXOs do I have? Or what market listings are out there for this token? Or any of that kind of stuff that's really, it's really custom to our business logic in this project. I can create my own routes for those. And so this is all very much, I'm just standing up. So I've got a top level namespace called OneSat, which is kind of for very specific OneSat queries. And I hope I might have a couple things broken here. So let's try this out. Okay, let me copy our token ID again. So if I go to / OneSat BSV21 and then a token ID. Oh, not a post. This is a get. Okay, so this is basically just you pass in any token ID, and assuming this overlay knows about that token and it's following that token, it's going to give you back kind of that token definition. So here's where it was minted. Here's what the symbol is. Here's the token ID, which is obviously going to be the same thing as where it was minted. We've got an icon field that was deployed with it that just tells you the icon to use when you display this. We've got the number of decimals it's configured with, which that's kind of a BSV21. Well, actually, that's pretty much every fungible token on a blockchain works that way. You don't actually track, you always track the value as integers, but then it has a defined, like, okay, how many decimal places do you interpret from that integer? So anyways, and this is amount. So in Money's case, they minted the full amount to like some separate vault that those are essentially unreleased coins. And then as coins get released, they get spent out of that vault and into circulation. So when they created them all, they created the max possible amount. But they're the only ones that are valid are ones that have been released from that vault. So those don't actually count toward a full supply. But that's their stuff. I don't know. I'm speculating. Okay. So we can get the details for a token. We can also let's see here. Move this over here. I don't even know if I own any money, but I know I do somewhere. I just don't know which wallet it's in. Not that wallet. This wallet. What is my address? Okay. So within that token ID, I should be able to look. So Money uses the cosign lock. So I'm going to look for where cosign, and that's my testing address. And I want to look at my balance. There you go. I have $250 of money. So you can get your balance, you can get your UTXOs. I'm really still working on exactly what these APIs need to be. There's another one that's like, let's see here, block. And then let's see if I can figure out what block I would have received these in. All right, so we can like query, okay, which money transactions happened within this block? And then these, I guess it's just one transaction happened in that block, and this is mine. So there was 300 money that went in, 50 that went out to someone, and the money fee of 10 or a tenth of a cent. No, 10 cents, 5, whatever, 1 cent. I don't know. 5 decimal places, and we have 4. So yeah, 1 cent. And then my change back to myself. So again, I'm still kind of working on what the different queries are that are available and how you get to them. But it's working, it's syncing. So in fact, actually this record that we just queried, that just means this crawler over here is already past that point. Because when I started up, this database was completely empty. There was nothing in it. But it's syncing. It synced up to those things. It found my coins. And so I have my own copy right now of the money ledger. And then ideally, like with money, for example, I'm sure that they will be broadcasting all their transactions into these overlays. We start up like at Gorilla Pool running any instances for people, that will be one, both kind of a source for everyone to sync with and also a mechanism to ensure. I mean, there's this whole other layer of problems that need to get solved. And there's lots of tools now out there to solve them. But for simply, how do you connect up with peers? And there's definitely work being done in that regard, but it's also something that it's still being worked on. So much to figure out, but that's that. So just wanted to share. Love any feedback anyone's got. I'd love anyone who wants to come figure out good mechanisms for peer-to-peer discovery and liveness and all that kind of stuff. Like those are definitely problems that need to get solved. The same overlay concept works for pretty much everything. It will not work for things like first is first mints, which is why I pretty much moved away from those, because there is no way. That's like BSV20. That's like I don't even remember. Not bitmap, but BSV map, or any of these things that says, okay, if I just deploy this thing on chain first, then I have it. That's cool. And if you've got something that can keep track of all that, that's great. But the problem is you can disprove that something was on chain first. You can say, okay, here is one evidence of this token being deployed before where you appeared on chain to deploy it. So you can disprove that something was first, but you can't actually prove that something was first without scanning every transaction on chain before it to prove that it wasn't also that thing. And that's just really not, it's not really peer-to-peer syncable. So that's always going to require someone being trusted as an authoritative source, because they can't give you proof otherwise. With these overlays, they are giving you the full proof. Like when these two overlays sync with each other, like it is validating every bit of proof. It is validating against blockchain headers. It is validating Merkle paths. It is doing everything to know that this is what I'm getting. What I got is what is. And if it didn't provide enough proof for you to validate it, well, it's not valid. Now, there's actually, I say that within this BSV21, because there's some little edge cases. There are cases where your overlay can get a transaction. Your overlay can know that it isn't yet synced up with kind of all the dependencies to be able to handle it. And it can just kind of say, I can't process this yet. So it's not saying I have processed this and it's not valid. It's just kind of airing out, saying you got to get back to me later. And that's only going to happen if you get some out of order syncs, and a good sync process should make sure that can't happen. So, but where it is right now, if it's syncing and somehow, actually, I don't even know how that would happen. Oh yeah, I do. So let's say there's some mempool transactions that happen that you haven't yet had synced down to your overlay. And then someone spends from one of those. And then you get synced to that transaction, and you can see the inputs, and you can see that you can see that the inputs are BSV21 inputs, and they are the right token, but you don't know about them yet. And so usually when you process a transaction and nothing matched the overlay, it'll actually store it and say, this doesn't belong to this overlay. And so next time it gets that transaction, it's not going to try and do it again. Well, there's one case that is built in here that if it hits that point, it's actually just going to kick it. It's not going to say, I've already tracked this, and it's not. It's going to say, okay, next time I get this from another source, I can process it once I've got the prerequisites, which also need to get synced from another source. This whole solution, everything we're talking about here in kind of the Terra node era and kind of big block Bitcoin, like everything can get handled in very, very small modular pieces. And so the tools aren't trying to solve the entirety of this is what you need to do. It's more like in the case of the overlay here, Like it'll process any transactions you feed it. How you feed it is completely another layer altogether. So like ideally you get your whole network set up such that people are broadcasting through the overlays and the overlays are syncing with each other. And that is ideal world. That is how this all needs to end up. But for instance, in here right now, I actually have a background Jungle Bus subscription. It's just making sure that, okay, it's completely separate from the overlay. It's just looking at every transaction that fits a given token and basically says, hey, if you haven't seen this one, you need to take a look at this one. So, but it's still submitting it into the overlay the exact same way that a user would, with full proof and everything of, here's the beef, here's the inputs, here's where their Merkle proofs for those transactions are, verified against your own block header service, and boom. I know that this happened. I know this is on chain, and I know this is good. All right, I'm gonna leave this here for now. Got some more. Yeah, got some more planning to do. Actually, let me go one step deeper. So we didn't really talk about lookup services. So topic manager was, again, let's look at a transaction and let's sort it and figure out if it belongs within the scope of this topic of this overlay. Lookup service is kind of different. This is like after that filtering process has already happened and the overlay knows that a certain transaction output is included in the overlay, well, then it's going to call this output admitted by topic method on this lookup service. And the lookup service, basically what it gets, let's look at, so it gets what the topic is, what the out point is, the Satoshis and locking script for that output, and then it actually gets the full beef proof of everything that's this whole transaction. So many lookup services can just ignore that. They don't need to parse all that information. But in my case, we actually do, and so it's nice that it's there. So basically, you're getting here, this output is included in the overlay service. Here is the transaction in which it happened, and then your lookup service then basically can do whatever it wants with that data to be able to store it such that you can then have people look up data into that lookup service. So for all of the overlays I've been building recently, I built. I don't have it on this computer. Let me see if I can get this open here. So I actually have, this is also under the BSV or the B Open IO namespace organization in GitHub. It's just called overlay. Needs a better name. It's some sort of tools or tooling. So within the Go Overlay Services project, there's a couple kind of like standard interfaces that are defined. So one is this storage interface, which I don't actually know if I have a good. Let me see if I can click through to it. No, my references are not set up. Anyways, so it's got the standard storage interface, which is kind of like different lifecycle events that can happen in the overlay, and the main implementation, the kind of core library, doesn't actually have a data implementation for that. So this is where I've got kind of my Mongo and Redis and SQLite implementations. And they're all using this kind of extended event data storage library I've got. So within the main, let's actually open one of these up. Let's go to the Mongo one. Okay, so a lot of these are kind of that storage interface that's defined in Go Overlay Service. So we've got an insert output. We've got a find output, find outputs for transaction, find outputs for topic, delete output. So these are all very much kind of at, I guess I'm going to say, at that topic manager level. These are all about tracking simply which outputs belong to a given topic. So most all this is just for working with that data. So it's not really at that lookup. So at that lookup service level, that's where you start kind of taking and putting your own spin on your your own business rules and that things that you want to identify or the events that you want to capture or whatever for the transactions that are flowing through here. So all of these, insert applied transaction, does applied transaction exist? Okay, so everything that's collapsed here is part of that standard interface that every storage adapter, every storage implementation needs to implement. But I have this kind of standard extension to this, which I'm actually using. So I'm using the same database connection for my topic manager and my lookup service. So if I go to my lookup services over here, nope, that's in here. So this is actually, I don't want to say this. So I've got a lookup service that's all about understanding BSV21s. And within kind of the standard mechanism I've got here is this simple little event interface that basically allows you to put a tag on an output or many tags on an output. And then those tags are sorted by the block height and block index on chain. So whatever different tags you want to build, you build, and then you can simply look up things in the database based on those tags. So for BSV21 here, let's see here. So one of the events I have is sim : followed by the symbol. So that simply means you can search token outputs by the symbol of that token. Looks like that's actually only mints. And that's other stuff. So if it's owned by a pay to public key hash script, we actually build an event here that is pay to public key hash, followed by the address, followed by the token ID. So all these things are, these events, they're just, you can do prefix searches on them. So if you just want to find all the outputs for a given address, regardless of which token ID we're looking at, which would only be obviously all the tokens that this overlay knows about, you can do a query for just p2pkh : address and put a wildcard at the end. And it says, I don't care which token, I want all tokens. So all these different events, they're just, you can do prefix searches on them so you can kind of build them in order where they are less specific, growing to more specific. And then they're pretty powerful just to be able to quickly get outputs from the overlay that are tagged with in certain ways. So this cosigner here, this is the money locking script. They don't use pay to public key hash, they use cosigner. So we store the cosigned address. If it's locked to mint, we store what the token ID is there. If it's a POW20, we store what the token ID is there. If it's a ordinal lock listing, we'll store that there. So essentially just all the different ways that you can quickly query this overlay and say, okay, what are all my money tokens that are listed for sale right now? Now, money actually can't use the ordinal lock contract because of how their stuff works. But any other token, like your bamboo token, like what bamboo token orders are available right now? Well, you'd ask a bamboo overlay a query that says, okay, I want all the listings for this token ID. And it'll just give you all the UTXOs where there's a listing for that token ID. A lot of these different events and stuff. I mean, at this point, they're not, it hasn't thought out all use cases or anything, but essentially then there's just a call of save events. That's going to pass in an array of these events, which are what you can search this thing by. And then they can also kind of stick some arbitrary data, which in this case is this BSV21 data right here. So when you get the records back, you can actually tell what you're looking at. You don't have to parse the transaction yourself necessarily. Yeah. And so then when we do these kind of lookups right here, so let's go back to the Are you going to make me get my address again? Oops. So when it does this, gets this balance. So what it's really doing is it's doing a query of our outputs where events is, and it's cosine followed by address followed by token ID. And so this is showing all of the outputs that my address that I post in there has ever owned. And then if I throw another thing on there that it, oops, where I say spend is null, now it's only going to give me the ones that are unspent. So that's really where all of this stuff is coming from. Is it's just using those. It's using those events to get down to the outputs that apply. And then within here, that's where the BSV21 data is stored. This is a totally kind of generic object. You can stick data for any different lookup service you want in here, and you'll be able to query it the same way. And then here are the events that are associated with this output. So for every BSV21 output, we're storing that it is of this token ID. And in the case of a cosine lock, we're storing the cosine followed by the address followed by the token ID. In the case of a regular old pay to public key hash, it's P2PKH. In fact, if we go, well, all of these are all money. So all of these are going to be cosine because that's how money does all theirs. Alrighty, that's probably enough for tonight. I will try to share more as I have more to share. And if anyone's got any questions or is interested in jumping in and playing with this stuff or whatever, please reach out. Talk to you later. Good night.